हेलो स्टूडेंट्स। आज हम कूलम्स लॉ पर कुछ और न्यूमेरिकल सॉल्व करेंगे। हियर यू सी क्वेश्चन नंबर 1। Three charges 1 microcoulomb and 2 microcoulomb are kept at vertices L, M and N of an equilateral triangle LMN of 10 centimeter side. What will be the resultant force on the charge at N? You have noted the question. Now come to the solution. Three charges: 1 microcoulomb, 2 microcoulomb, 1 microcoulomb, 1 microcoulomb and 2 microcoulomb are kept at the vertices of a triangle. Equilateral triangle. L, M, N. And then the charge is 1 microcoulomb. It is positive charge. At M again it is 1 microcoulomb. And at N it is 2 microcoulomb. These charges are positive charge. We want to find force at charge kept at point N due to charge at L and at N. The side of the triangles are 10 centimeter. It is equilateral triangle. Now using the Coulomb's formula, calculate the force on charge N due to charge at L. The solution. Force on charge on the charge at N due to charge at L. Okay, so electric force on the charge at N due to the charge at L. Since both charges are positive, therefore this force will be repulsive. This charge will repel this one. What will be the direction? The direction will be here, like this. Say this force is F1. F1, repulsive force between 1 microcoulomb and 2 microcoulomb. F1 is equal to K Q1 into Q2 by R square. Here Q1 is 1 microcoulomb. Say it is Q1. This one is Q2. And suppose this is Q3. Force between this Q1 and Q2. K Q1 into Q2 by R square. K is 9 into 10 to the power 9. Q1. 1 microcoulomb means 1 into 10 to the power minus 6 coulomb. Q2. 2 microcoulomb. 2 into 10 to the power minus 6 upon R square. It is 10 centimeter. So in meter it will be 10 into 10 power minus 2 square. Clear? Now its value will be 9 to the 18 and minus 6 minus 12 and this 9 is plus, so it will be 10 power minus 3 upon what will be this value? It will come 10 power minus 2. When we will transfer this 10 minus 2 to numerator, it will become 18 into 10 power minus 3 into 10 to the power 2, that is 18 into 10 to the power minus 1, or we can write it 1.8 Newton. We have got F1 is equal to how much? 1.8 Newton. Now we will find force on this charge at N due to charge at M. Again, both charges are of same nature. There will be repulsive force. It will act in this direction. In this direction. Suppose this force is F2. So F2 is equal to how much? F2 is equal to, again we will apply Coulomb's formula, K Q3 into Q2 by, the side is 10 centimeter, it will be converted into meter. Say this is again equal to R square. We were 9 into 10 to the power 9 into 1 into 10 power minus 6 into 2 into 10 power minus 6 by 10 into 10 power minus 2 square. Again the same value as it was F1. So this F2 is equal to 1.8 Newton. Now we have got two forces which are acting at the charge at point N. F1 is equal to 1.8 Newton and F2 is again, it is also 1.8 Newton. Now what will be the resultant force of these two? We will calculate the resultant force. Since LMNI is an equilateral triangle, so the angles will be 60 degree each. And this one is vertically opposite angle, so this angle will be also 60 degree. Now we have two forces, F1 and F2, acting at point N at angle 60 degree. So the resultant force acting on the charge at point N will be resultant force on the charge at N, F is equal to under root F1 square plus F2 square plus 2 F1 F2 cos 60. You know this formula, you have studied this formula in class 11, how to find the resultant of two forces. We will use this formula. Now put the values. F1 is 1.8 square plus 1.8 square plus 2 into 1.8 into 1.8 cos 60. Cos 60 is how much? Cos 60 is 1 by 2. Now this 2 and 2 cancel out. So we will have 1.8 square. How many times? 1, 2, 3 times. Into 3. And it will be 1.8 root 3. Put the value of root 3. It is 1.8 into 1.732. Now multiply these two. Find the result value. It will come equal to 3.1176. Nearly 3.12. We'll find that it will come nearly 3.12 Newton. So the resultant force on the charge at point N due to these two charges is 3.12 Newton. This is the answer. Clear? Now, second question. A charge Q, small q, is placed at the center of the line joining two charges, each equal to Q. If the system of these three charges will be in equilibrium, then what should be the value of Q? Here we have two charges. These two charges are equal to capital Q. Two charges. Suppose capital Q charge is placed at point A and this capital Q charge is placed at point P. The distance between these two charges, suppose this distance is R. Clear? Now the third charge, which is Q, small q, it is placed at the midpoint between the two charges. Suppose this is the midpoint. Say it is C point. At C we have charge small q. Clear? Now what will be the distance between small q charge and capital Q charge? Whole distance is capital R. Suppose then this will be R by 2 and this will be also equal to R by 2. Clear? Now the system of these three charges, Q, small q and capital Q, this system is in equilibrium. I have taught you in class 11 that a system will be in equilibrium if the net force on the system is 0. If the net force on every part of the system is 0. Now this system will be equilibrium when net force on Q is 0, net force on small q is 0, net force on capital Q is 0. We will take one charge, this suppose Q at point B. We will find the net charge at point B. This system will be equilibrium if the net charge at this charge Q is 0. Find the force at Q because of force at point A. Suppose write the net, the system. This system will be in equilibrium if net force on the charge capital Q at B is 0. You can take any one of these three. You can take this one or this one. I am taking suppose this charge B. Now find the force, total force acting on Q. Total force acting on Q are force due to A plus force due to charge at C. Suppose this point is C. We have taken C. That is force between A, charge at A, charge at A plus charge at A, force between charge at A and B. Charge at A, force between charge at B due to charge at A. Suppose this is FBA. We will call K, Q1, Q2. Both charges are capital Q, Q, Q by distance is R square. So charge this is equal to K, Q square by R square. Force at charge at charge capital Q at B due to charge small q at C. It is FBC. FBC is equal to K, Q. Now this charge is small q, and the distance between small q and capital is R by 2. R by 2 square. It will come equal to K, Q by R square, and this R square by 4. 4 will come here. So 4 times and K. Now we have got the two forces which are acting at Q. Now the sum of these two forces must be 0 so that the system is in equilibrium. Therefore, in equilibrium, FBA plus FBC is equal to 0. This implies that K Q square A by R square plus K into 4QQ by R square is equal to 0. Now, solving this, we will get this Q is equal to how much? Q plus 4Q is equal to 0, or Q is equal to minus Q by 4. So the value of this charge Q is minus Q by 4. That is opposite of charge Q, and 1/4. Then this system will be equilibrium. Clear? So we have got the answer. The value of small q is q by minus q by 4. Third question. Note down. Third question. 4 equal charges, each of 2 microcoulomb, are placed at the corners of a square of side 1 meter. Find the force on the charge at A. Here it is given in the diagram. A, B, C, D are the 4 corners of the square of side 1 meter. 4 charges Q1, Q2, Q3, Q4. All these 4 charges are equal and equal to 2 microcoulomb, positive charge. We want to find net charge acting at point A, that is at charge Q1. So then we will calculate the force on charge Q1 due to charge Q2, force on Q1 due to charge Q4, force on Q1 due to charge Q3. So if you want to find Q3 charge force on charge Q1 due to Q3, then you have to calculate the distance AC. This is the diagonal. You have to find this, and it is diagonal of this square. Applying Pythagoras theorem, because this angle is 90 degrees, applying Pythagoras theorem, this AC square is equal to AB square plus BC square. That is, AC is equal to under root 1 square plus 1 square. That is, we have got that AC is equal to root 2. This is root 2 meter. Now force on charge Q1 due to Q2. Q1 and Q2 both are positive, so force will be repulsive. It will repel along this direction. This is the force. Suppose this is F1. Force on charge Q1 due to Q2. F1 is equal to K Q1 into Q2 by, what is the distance? AB square. This AB square. That is 9 into 10 to the power 9 into Q1 is 2 microcoulomb, means 2 into 10 power minus 6 into 2 into 10 power minus 6 divided by distance is 1 meter, 1 square. Clear? Now 9 to the 18 to the 36. It is 36 into 10 to the power minus 6 minus 12 plus 9, it will come minus 3 Newton. This is F1. Now force acting on Q1 due to charge Q4. Again, these two charges are positive. It will be repulsive. The force acting on Q1 will be in this direction. Suppose this force is F2. Force on charge Q1 due to Q4. F2 is equal to K Q1 into Q4 by distance between Q1 and Q4 is 80. 80 square. That is 9 into 10 to the power 9 into Q1 is 2 into 10 power minus 6 into 2 into 10 power minus 6. Q1 and Q4 divided by 1 square. Distance is 1 meter. Again we will have this F2 is equal to 36 into 10 power minus 3 Newton. Now the force on Q1 due to Q3, it will act along this CA, that is in this direction. This one. This is suppose F3. Force on charge Q1 due to Q3. We will have this F3 is equal to K Q1 into Q3 by AC square. The distance is AC square. This is 9 into 10 power 9 into Q1 is 2 into 10 power minus 6 and Q3 is again 2 into 10 power minus 3. All the charges are equal and distance is 1 meter. No, it is root 2 meter. Root 2 square. Root 2 square 2 and 2 to cancel out. So we will have this F3 is equal to 18 into 10 power minus 3 Newton. Clear? Now, this is 2 into 10 power minus 6 into 2 into 10 power minus 6. It is minus 6. So minus 6 minus 6 minus 12 and 9. 9 plus, we will get 10 power minus 3. We have got three forces, F1, F2, F3 acting on charge Q1. This F1 and F2 are at right angle with each other. So we will find the resultant of these two. And this F3 is making 45 degrees with this one. So resultant of F1 and F2 will be along F3. So first of all, calculate the resultant of F1 and F2. Resultant of F1 and F2. Resultant force of the forces F1 and F2. This is F is equal to under root F1 square plus F2 square. 36 into 10 power minus 3 square plus 36 into 10 power minus 3 square under root 2 times the same quantity. So we will have 36 into 10 power minus 3 into root 2. It will be equal to 36 into 10 power minus 3 into 1.414. So we will have multiply these two. What will be the value? It will be nearly 50.90. 50.90 Newton. This is multiplied by 36. This 1.4 10 power minus 3 power into 10 power minus 3 Newton. Now this force F, which is the resultant of F1 F2, will be in the direction of F3. This force F is in the direction of F3. Therefore, net force on Q1 F dash is equal to F plus F3. That is, F is 50.90 into 10 power minus 3, it is minus 3 into 10 power minus 3 plus 18 into 10 power minus 3. So we get how much? It is 68. 09.86 68.90 into 10 power minus 3 Newton, or you can write as 6.8 or 0.0689 Newton. Clear? Okay, I will give you some questions for homework. Please note down.